Assalamualaikum. The lecture 2 of DSP is about signal system and its basic operations. So first of all, I will tell you the system. What is system? So system is any process that produces an output in response to an input signal. So this is an input signal. When we apply it to the system, it will create an output at the end of the receiver. So the basic operations on the system, there are the three basic operations on the system that we will apply to the original signal. The first one is flip. This is the function. When we will put the values of n in this function, we get the different values, and these values will apply to the system. This is an original signal, and we will get the values and draw an output signal at the end. So we can see that this is the original signal and this is the output signal. This side will turn over to this side and this side will turn over to this side in flip operation. Now the shift operation. Shift operation contains the advanced mode and the delayed factor. In advanced mode, we will add some integer value, and in delayed factor we will subtract some integer values. This is the function. When we will put the values of n in this function, we get the values, and from these values we will draw the signal. We can see that this signal shifted towards the left side with integer 4 because when we will add 4 number to this function, then the signal will shift it towards the left side with 4 integer. And in this case the signal have the delayed factor because we will subtract the signal with, when we subtract the function with 2, we have the delayed factor in this receiving signal. In this receiving signal, we know that the signal will shift towards the right side with the factor of 2. The third one is the scaling operation. In this operation, the signal will become shrink and the signal will become expand. If we multiply the function with some integer, the signal shrinks, and if we divide the integer with some function, then the signal will become expand. In the shrinking function, when we put the values, different values of n, the receiving signal is this, and when we divide the function with some integer, the receiving signal is this. In the expanding signal, we can see that there are some values at which the signal will become 0. Here is the combination of the previous operations. Now this is the signal. This signal contains the shift, flip or scaling operation. So the order that we will follow, that this is the first one, the shift, the second flip, and the third one is the scaling order. This function will divide it into 3 sub-functions, in which the first one is shifting, and the second one is flip, and the third one is scale. So if we put different values of n in this function, we will get the shifted operation, and if we put different values of n in this function, we will get our flip operation, and if we will put different values of n in this function, we will get this signal. So as we discussed earlier, this is the original signal, and if we expand it by dividing the function with 2, this signal that we will get at the receiver end. So we can see that these are the numbers on which the signal will become 0. So this is basically the error, and this error can be removed by 3 functions, that is 0 order hold, first order hold, and the second order hold. Basically in this function some information will lost, and that is, in 0 order hold we will get the values on these values, that this value draw by the previous value like this, and this value will draw same as the previous value like this. Similarly, this value, similarly, this value, similarly, this value. In this way, we have the signal like this function. This is the zero order hold, in which we will draw the same value on the zeros from the previous values. The first order hold contains the trapezoidal rule and the Taylor series. In this order, we have two factors. First one is simple f of x, and the second one is its derivative with multiplication of h. This is basically the slope, and the slope formula is equals to y2 minus y1 divided by x2 minus x1. So this is the expanding signal. If we take the average values of this and this signal, we have the slope. This is the value of y2, y1, x2 or x1. If we put these values in this function, we have some value that is equals to 1.5, 0.5, 0.5, 1.5 and 0.5. So this is all about the first order hold. In second order hold, we need three samples. Simple function, first derivative with multiplication of h, and the second derivative with multiplication of h squared divided by 2 factorial. In this order, we take the average values of these two signals and contains the middle value. Similarly, average value of these two signals contains the middle value. Similarly, average value of this signal contains, and this is the middle value. In first order hold, we will get the slope, and in second order hold, we will have curves at the end of the signal. In DSP, here is the special signals that we will use in DSP. The first one is unit impulse and the second one is unit step signal. In unit impulse function, when the value of n is 0, the signal is 1, and when n is not equals to 0, the signal will become 0. In case of unit step function, when n is greater than equals to 0, the value of the signal is 1, and when n is less than 0, the value of the signal is 0. Here is the common signal decomposition. The common signal decomposition contains the unit step decomposition and the unit impulse decomposition. And here is the even signal and the odd signal. In even signal, the formula is this. So this is an original signal, and if we will flip the signal, we will get x of minus n divided by 2. In even signal, at the negative side, the signal is this, and at the positive side, this is the mirror image of negative side. In case of odd signal, the formula is same, but here is the negative sign. And if at the negative side, this is the signal, and in case of positive side, this signal will becomes inward. So this is all about today's lecture. Thanks for watching. Allah Hafiz.